Okay, this is the second part of section 1 in chapter 4. We're going to be looking at how we can use radians to get things like arc length and angular speed. So, formula for arc length, which is of course this distance. So it's a circular distance. Okay, I'm measuring a circular line. Okay, what we do is we take the radius, okay, and we multiply it by the central angle. Central angle is an angle that is at the center of the circle that creates the arc. Now, when I multiply it by this central angle, that has to be in radians. Okay, if you try to multiply it by degrees, you're going to get something that is completely wrong. So this is one use of radians. So here's the basic formula. S equals r theta. S is arc length, r is the radius, and theta is the central angle in radians. And we can use this to find any missing piece. So maybe they tell us what S is, and they tell us what theta is. We can use it to find r, okay, by solving this equation by inputting the given information. We can also find linear speed. So linear speed is, of course, the speed that we're used to thinking about. It's distance over time. But in this case, our distance is going to be an arc. Okay, so it's going to be a curved distance. So if I'm running along here, how long does it take me? That's how fast I'm moving in a linear speed. There's also an angular speed, so that's how fast the angle is changing. So let's say I do that again. I'm still running along this curve. So I have a linear speed, okay, that'd be like feet per second or miles per hour, whatever it is. But I also have an angular speed because what I'm doing is I'm moving this line, okay? So if think of it as this line's moving, so I'm changing an angle. Okay, how fast am I changing that angle I'm making with the center? Okay, so that would be angular speed. How quickly is this central angle changing? So that is just theta, or theta is the central angle again, divided by the time that it takes. So the change in your angle divided by the time it takes for you to change that angle by that amount. That's angular speed. We can think of it as change in S, change in time, change in the angle, divided by change in the time. So here's some examples. First, let's say that they give us this information. Okay, so this is 31 inches, and my radius is 12 inches. I want to know what angle this is. Well, I know that 31 equals r theta, so 12 times theta. So I'm going to divide by 12. And I'm going to get, let's bring in my calculator here. Okay, so I'm going to take 31 divided by 12. Oops. Which I don't think reduces at all. Yeah, so it's 31/12, and that's how many radians this angle is. Okay, because radians can be numbers like that. If you want to think of it as a decimal, it'd be 2.583 repeating radians. Just as a reference, you should always keep in mind what pi is. So I get 31/12, which is 2.583 repeating. Now, this is, pi is 3.1415. Okay, so this is less than pi, because remember this angle would be pi. So it is less than that, okay? So that's kind of a good way to check your answer. Let's see, next one. Let's say it takes an ant 10 seconds to move along this arc up here. What is his linear and his angular speed? Well, his linear speed is just the distance he's traveling, which is 31 inches. It takes him 10 seconds. So that would be 3.1 inches per second. His angular speed, okay, he's moved this many radians now. 2.583 repeating in 10 seconds. Okay, that's how many radians he's moved in 10 seconds. So that's going to be 0.2583 repeating radians per second. Okay, so every second he's going 0.25 radians, which would be, if we take that as a fraction of pi, so divide by 10, and then divide it by pi. So it's about 8/100ths of pi. Okay, so every second he's moving 8/100ths of pi degrees. Okay, here's the type of word problem we might have using this. An electric hoist is used to lift a piece of equipment 2 feet. That should be feet here. Okay, the diameter of the drum on the hoist is 10 inches. So usually when you have word problems, if it might help you to draw a picture. So I've got this drum. It's 10 inches across, and there's a chain on it. Okay, this chain wrapped around it here. Chain's going down, and it's attached to some item. And I need to raise this from here up to here, where this distance is 2 feet. So I need to figure out how many rotations it's going to take for me to get that. So I'm going to be winding up. I need to wind up 2 feet worth of chain on this, because if I wind 2 feet up, that's going to raise this by 2 feet. So 2 feet is the angular, is really the arc length that I'm looking at. So 2 feet equals R. So R, since I have a 10-inch diameter, my R would be 5 inches. Okay, and right here there's a problem. I've got feet versus inches. I need them to be in the same units. So I'm going to change 2 feet into 24 inches. So 24 inches is 5 theta. So I'm going to find out how many radians I have to rotate, and I'm going to convert that to degrees. So I'm going to divide by 5. Okay, and I get 4.8 radians. Okay, and I know that there are pi radians in 180 degrees. So I can use this as a conversion. So take 4.8 times 180 and then divide it by pi. So that's how many degrees I have to rotate. 275.02 degrees. I'd have to spin the drum that many degrees, which isn't quite a full circle even, in order to get 2 feet to go up. To check this, to make sure I wouldn't actually have to do a full circle, we just find the circumference of this. So if I take 2 pi r, which is 2 pi 5, that'll tell me how much one revolution of this would be. So if I were to spin around one full time, how much chain I would be wrapping up. So 2 times pi times 5, 31 inches, which is more than 2 feet. So this answer makes sense. Okay, and those are some examples. So you should be able to finish the second part of the Section 1 assignment.